Imagine soaring through the sky, thousands of feet above the ground. The world stretches out beneath you, a tapestry of fields, cities, and clouds. How do pilots navigate this vast expanse, finding their way from one point to another with pinpoint accuracy? Aerial navigation is a complex and fascinating art, requiring a combination of skill, technology, and constant awareness. Just as drivers rely on roads and maps, pilots use a sophisticated system of routes, instruments, and communication to reach their destinations safely. On the ground, navigation seems relatively straightforward. We use landmarks, road signs, and GPS devices to find our way. But in the air, things are different. There are no roads or signposts in the sky. Pilots rely on a combination of visual cues, sophisticated instruments, and air traffic control guidance. They must be able to visualize their position in 3 dimensions, constantly adjusting their course and altitude to account for wind, weather, and air traffic. Under ideal conditions, pilots use visual flight rules or VFR. This means they rely primarily on what they can see outside the cockpit, landmarks, terrain features, and other aircraft. Imagine a pilot flying a small plane on a clear, sunny day. They can see for miles around, using rivers, highways, and towns as visual reference points. They can also see and be seen by other aircraft, maintaining safe distances visually. However, pilots can't always rely on visual cues. When flying at high altitudes or in challenging weather conditions, the view outside the cockpit can be obscured by clouds, fog, or even darkness. In clouds, fog, or at night, visibility is limited. This makes it difficult, if not impossible, for pilots to navigate using only their eyes. They need a reliable system to guide them safely. This is where Instrument Flight Rules, or IFR, come into play. IFR is a set of regulations and procedures that pilots follow to fly aircraft when they can't rely on visual references. It ensures that they can navigate, communicate, and land safely. IFR allows pilots to navigate and land safely even when they can't see the ground. By following these rules, pilots can trust their instruments to provide accurate information about their position, altitude, and speed. They rely on instruments like the artificial horizon, which shows the aircraft's orientation relative to the horizon, the altimeter, which measures altitude, and the heading indicator, which helps them maintain their desired direction. These instruments are crucial for maintaining control and following precise flight paths, especially in poor visibility conditions. Imagine a pilot flying through a thick layer of clouds. The outside world is completely obscured, and they can't see anything beyond the cockpit windows. They can't see anything outside, but their instruments provide all the information they need to stay on course and at a safe altitude. These tools are their eyes in the sky, guiding them through the most challenging conditions and ensuring a safe journey. Section 5. Aerial highways, navigating the airways. To ensure order and prevent collisions, airspace is organized into a complex network of aerial highways called airways. These airways are like invisible roads in the sky, defined by specific altitudes and routes. Think of these airways as multi-lane highways in the sky, with different lanes designated for aircraft traveling in opposite directions. Pilots receive clearance from air traffic control to enter and exit these airways, ensuring a smooth and organized flow of traffic. Section 6. Beacons in the sky, VOR and NDB. For decades, pilots relied on ground-based navigation systems like VOR, which stands for Very High Frequency Omnidirectional Range, and NDB, or Non-Directional Beacon, to navigate airways. These systems work like radio beacons, emitting signals that aircraft can use to determine their position relative to the station. While still functional, these systems are now often used as backups to more modern satellite-based navigation. Section 7. Space-Age Navigation, GPS and beyond. Today, the Global Positioning System, or GPS, has revolutionized aerial navigation. Using a network of satellites orbiting Earth, GPS receivers can pinpoint an aircraft's location with incredible accuracy. Imagine a pilot entering their destination into a GPS unit. The system calculates the most efficient route, provides real-time guidance, and even displays potential obstacles along the way. GPS has made navigation more precise and efficient, reducing workload for pilots. Section 8. Traffic control in the sky, the guardians of flight. Just like traffic lights and road signs on the ground, air traffic control, or ATC, plays a crucial role in maintaining order and safety in the skies. Controllers on the ground use radar and communication systems to track aircraft, provide clearances, and prevent collisions. Imagine a busy airport with dozens of planes arriving and departing. Air traffic controllers act like orchestra conductors, guiding each aircraft through the complex airspace, ensuring they maintain safe distances and follow designated routes. Section 9. Inside the cockpit. A look at the instruments. The cockpit of an aircraft is a marvel of engineering, filled with instruments and displays that provide pilots with vital information about the aircraft's performance and position. The altimeter shows altitude, the airspeed indicator displays speed, and the heading indicator shows direction. Other instruments monitor engine performance, fuel levels, and weather conditions. Imagine a pilot monitoring these instruments during flight, constantly making small adjustments to maintain altitude, speed, and heading. Section 10. Weathering the storm. How pilots navigate turbulent skies. Weather plays a significant role in aviation, and pilots must be prepared to navigate challenging conditions. From the moment they begin their training, pilots are taught to understand and respect the power of nature. They learn to read weather patterns, interpret radar data, and make quick decisions to ensure the safety of everyone on board. Wind, storms, and fog can all impact visibility and flight paths. These elements can create turbulence, which can be unsettling for passengers, but is something pilots are trained to handle. They know how to navigate through or around these conditions to minimize discomfort and maintain control of the aircraft. Pilots use a variety of tools to assess and manage weather. These include sophisticated radar systems that can detect storms and other weather phenomena from hundreds of miles away. They also rely on satellite data, weather reports, and real-time updates from air traffic control to stay informed about changing conditions. Weather reports, radar systems, and communication with ATC provide crucial information about current and forecasted conditions. This constant flow of information allows pilots to make informed decisions about their flight path. They can adjust their route, altitude, or even delay or cancel a flight to ensure safety. They can then adjust their route, altitude, or even delay or cancel a flight to ensure safety. For instance, if a pilot receives information about severe turbulence at a certain altitude, they might choose to fly higher or lower to avoid it. Similarly, if a storm is expected to hit their destination, they might decide to land at an alternate airport. Imagine a pilot encountering a thunderstorm. Thunderstorms are particularly dangerous because they can produce severe turbulence, lightning, and even hail. Pilots must be able to quickly assess the situation and decide on the best course of action. Using weather radar, they can see the storm's intensity and location, allowing them to deviate around the most dangerous areas. This technology is crucial for maintaining safety, as it helps pilots avoid the worst of the weather and find a smoother path to their destination. In the end, the goal is always the same: to ensure a safe and comfortable flight for everyone on board. Section 11. Navigating the open ocean. A different kind of challenge. Navigating over vast stretches of ocean presents unique challenges. Unlike flying over land, where pilots can rely on visual landmarks such as mountains, rivers, and cities, the open ocean offers no such references. The vast, seemingly endless expanse of water can be both mesmerizing and daunting. With fewer visual landmarks and a greater reliance on instruments, pilots use a combination of GPS and inertial navigation systems, or INS, to maintain their course. These systems work together to provide accurate and reliable navigation data, ensuring that the aircraft stays on its intended path. INS uses gyroscopes and accelerometers to track the aircraft's movements, providing an independent source of navigation data. Gyroscopes measure the rate of rotation, while accelerometers measure changes in velocity. Together, they help pilots understand the aircraft's orientation and speed, even when GPS signals are unavailable. This is crucial in case of GPS signal loss or interference. In the middle of the ocean, where there are no ground-based navigation aids, losing GPS can be a significant challenge. Pilots must be prepared to rely on their INS and other backup systems to ensure they can continue their journey safely. Imagine a pilot flying across the Atlantic Ocean. The vastness of the water below, stretching as far as the eye can see, can be both awe-inspiring and intimidating. The pilot must trust in their training, their instruments, and their ability to navigate through this seemingly endless expanse. They constantly monitor their instruments, ensuring the INS and GPS data align, confirming their position and progress. This constant vigilance is essential to ensure the aircraft remains on course and reaches its destination safely. Aerial navigation is a complex and fascinating blend of skill, technology, and constant vigilance. Pilots must be adept at interpreting data from multiple sources, making real-time decisions, and adapting to changing conditions. Pilots rely on a sophisticated network of systems and procedures to navigate safely and efficiently, from visual landmarks to advanced GPS technology. This network includes satellite-based systems, ground-based aids, and onboard instruments, all working together to provide accurate and reliable navigation information. The next time you board a flight, take a moment to appreciate the intricate world of aerial navigation that makes modern air travel possible. Behind the scenes, a team of skilled professionals and advanced technology work tirelessly to ensure your journey is safe, efficient, and comfortable. From the moment the aircraft takes off to the moment it lands, every aspect of the flight is carefully managed and monitored, allowing you to sit back, relax, and enjoy the journey.